But the Ares, using boosters derived from the space shuttle, will be able to muscle an extra 22 tons of cargo on each trip to the moon.
So if you have very large rockets, you can have fewer launches in order to assemble the spacecraft that goes to Mars. So the large rocket is really a product of the desire to ultimately look at Mars in our exploration scenarios.
New hardware will also include Orion, the crew vehicle. It will be more than 2.5 times the volume of an Apollo capsule. On its missions to the moon, Orion will dock with a lunar lander sent into space on a separate launch. Unlike Apollo spacecraft, Orion will orbit the moon unmanned, while lunar explorations take place. The astronauts will redock with Orion for the return to Earth. This new crew vehicle will borrow much of its hardware from the space station.
And this is a place where few tourists come, so
in 1997, retired astronaut Jerry Linenger spent about 5 months, nearly the length of time it would take to get to Mars, aboard the Russian space station Mir. While on the long mission, he overcame many dangers, including the most severe fire ever on an orbiting spacecraft. A chemical leak ignited a blaze that lasted 90 seconds, threatening the crew.
I processed a lot of the things that I think pretty much saved our lives are these oxygen breathing devices, and during the fire, of course, that had to go on quickly.
If anybody knows firsthand how the hardware, including life support systems, will work on the spacecraft taking man to Mars, it's him.
Down here on Earth, you take so much for granted. You know, we're out here, sunshine, the fresh air all around you. You know, in space, you have to make it. You've got to make the oxygen. Up there, you're in a closed ecosystem. You have to recycle, you know, whatever you can.
And the toilet itself is over this way, and it's a very simple design.
For example, we take the urine, collect it using a little funnel, little suction device.
For the male or female urination is this tube here is used.
We'd collect that up, we'd convert the urine into water, water to oxygen, and we would breathe our urine inside that closed ecosystem of the space station.
Of life. I hope you got a feel for the space station as we flew you through it.
New hardware will also provide power from clean, reliable sources. We're going green to the red planet. Solar panels will do the job on the return to the moon. But the longer journey to Mars will require another power source.
As we get off to Mars, the solar insolation, the intensity of sunlight at Mars, is only about half that at the Earth. So solar panels are less effective. We may have to think carefully about using nuclear power sources in some of these spacecraft. And in fact, people are thinking seriously about nuclear power sources on the surface of the moon in order to generate long-term power and not have to worry about the periods of darkness on the moon where you don't have sunlight and you have to bring batteries up to store power.
But despite all the new hardware, the journey to Mars will still have its share of potential hazards. Just like any trek to an unfamiliar place.
Imagine you're on a wilderness camping trip. You leave home, the familiar surroundings that you're used to. You go out on a long trip, potential dangers, hazards, rock slides, avalanches, getting lost, equipment breakdown, all sorts of possible problems. But you want to go anyway. You prepare, you go out. It could be an adventure. It could be a disaster. Going to the moon and Mars is going to be like that too. You leave the familiar surroundings of Earth, you go out in space, potential problems, issues, equipment breakdown, many of the same kind of problems that you might have on a camping trip, the astronauts might face on Mars. It could be a challenge, it could also be a disaster.
A major hazard the crew will encounter will be prolonged weightlessness in the zero-gravity environment.
Easy in 0G. Oh yes, it's true.
Relieved of bearing its usual load, the human skeleton starts to deteriorate. There's a loss of calcium phosphate, a chemical critical to the rigidity of bones, and the number of bone cells actually decreases.
For 24 hours a day, you're floating, and your body very smartly starts physiologically to adapt to that new circumstance. So in order to counter that, try to keep your strength up, I get on a treadmill. At 2 1-hour periods a day, it's about all you can muster up there. In spite of that, came back at about 65% of my pre-flight strength level, a lot of muscle atrophy, and more significantly, about a 14% bone loss. Hips, lower spine. You get up in space, you're floating effortlessly, the bone just keeps dumping calcium. And that could be a showstopper on a long-duration flight.
It was only through intense physical training after his return to Earth that Lineker was able to reduce his bone loss from 14% to 2%. The debilitating effects of weightlessness remain an issue that must be addressed before we set foot on Mars, let alone colonize it. Research continues on a possible solution.
A lot of people have looked towards artificial gravity, which means you spin the spacecraft up and you end up with a gravity, and that would sort of help load your bones, because when you're in weightlessness, your fluids are shifting, your bones are unloaded, and you lose about 2% of your bone mass per month. It would be a large hurdle because in order for crews to be healthy when they arrive at Mars, they need to be strong for the entire trip.
Nobody's ever built a rotating spacecraft before, so nobody wants to be the first person. But most people believe that some kind of artificial gravity with a rotating spacecraft on the way to Mars is actually the way to do the mission.
Missions headed for Mars also face danger from solar storms. High-energy particle bursts unleashed from the sun could wipe out a crew if they aren't prepared for the onslaught.
So radiation is one of the largest showstoppers in terms of technology that needs to be developed for a future vehicle. The easiest way to deal with that is just make a storm shelter, so that if you can somehow predict when the solar storms are approaching, which you would do with various navigation satellites and relaying them from Earth, then you could get into the shelter and wait it out and then be able to go back into the spacecraft. And then similarly on Mars, when you know that there's a storm coming, you would go into a shelter.
The journey alone will make colonizing Mars an unprecedented challenge, but the enormous risks come with historic rewards. No decision is more important than who gets to go. Think you have what it takes to be a space pioneer? Get in line. There are people already training for the job. Colonizing Mars will require a special breed of people. With missions that could last more than 2 years, selecting those with the right stuff to be planetary pioneers will be critical to the success.
2, 1, we have ignition.
The cost of a launch in the billions of dollars and the tight quarters of the spacecraft will keep the number of crew people to a bare minimum.
I believe that number is 4. It's the smallest number you can send and divide the crew up into 2 groups and have no one be alone. And it's the smallest number that you can send in which you have the 2 primary skills of the mission both multiply backed up.
A crew of that size would consist of 2 ace mechanics who can fix anything, and in doing so, save lives. Joining them would be 2 field scientists, the intellectual payload.
So in Star Trek terminology, I want 2 Scotties and 2 Spocks.
Mars colonists will need more than just these vital skill sets. They also need to be mentally tough.
People think that astronauts are tough. They will just always obey commands and will operate according to plan. But they are human, and humans in these situations do develop strange psychological reactions. We really have to understand that, because that's part of the crew selection process.
All right, I'm going to fly into the node.
Astronauts will have to adapt to the confined space of the crew vehicle or habitat. If you're claustrophobic, forget it.
And we actually test for that. We put you in sort of a ball, zip it up, it's totally dark, you're crammed in the thing.
Inside the sleep cabin, there's also a little window. Sleeping bag sitting right here. This just happens to be the commander's sleep station.
And they have heart monitors on you. In my case, I fell asleep. They finally came, opened the thing up, said you're fine. But if you don't fall asleep in a closed space, you're not the right person.
Dealing with being the only life forms on an otherwise lifeless planet will be another major psychological challenge.
Out there in space, you truly are just removed from mankind. And, you know, the interactions we have in life with the colleagues, friends, family, you just sort of take them for granted down here. But up there, all of a sudden, it is isolation like I've never felt before. If you're not totally comfortable with yourself, you're going to have some very, very difficult times up there.
So it's been 4 months simulated Mars mission. Everyone's doing great.
To train people for this extreme mission, the Mars Society has built 2 Mars analog research stations to practice simulated missions. Crews consisting of as many as 6 people, mostly university scientists and NASA personnel, operate under many of the same constraints that astronauts will endure on Mars. They don't go outside without wearing spacesuits. They live on Martian time, 37 minutes longer than an Earth day. Their communication with Mission Control in Denver is on a 20-minute delay to simulate the time it takes for a radio signal to go from Mars to Earth. Maybe most challenging, they must coexist in a habitat with minimal personal space.
By doing that, you find out what works on Mars and what doesn't, and what kind of skill mix, what character mix you need in the crew, what technologies are likely to be most useful to the crew, how to organize the crew, who should command the crew, how tight you can ration the water and still sustain morale while you're doing this kind of work. This is not like a lunar mission which only lasts a week, where you can get 3 test pilots and they can just suck up the fact that they don't really like each other for that duration time and get along.
Crews first go to the Desert Research Station, located outside Hanksville, Utah, to conduct short-term missions lasting 2 weeks. During that time, they perform EVAs, extravehicular activities, such as collecting soil samples for geological study. After completing their desert work, the crews are ready to join longer missions, lasting up to 4 months, at the research station on Devon Island in the Canadian Arctic.
Devon Island is one of the key places that you can conduct Mars research because of its isolation. It's the largest uninhabited island in the world. There are no signs of life around, maybe some bacteria and algae growing on the rocks. And also because the crater formation that the research station is located on is similar to a crater that you would typically find on any planet. There's a lot of permafrost up in the Arctic, and drilling into there looking for microbial life could be a similar experiment to what you would do on the surface of Mars.
We're going on our radiation/weather station EVA. We'll be taking readings of the surrounding area.
In addition to conducting field research, scientists at both stations also study each other as part of what they call human factors.
The human factors research looks at the interactions between humans and computers, the interactions between humans and their environment, and with each other. By learning how we're going to react with each other in different situations, we can then learn how a crew will react together on the way to Mars or on the surface of Mars.
A lot of our findings sound very obvious, but they have not really been paid attention to before. For example, the very first thing you learn is that this activity, a field exploration while wearing a spacesuit, is a physical activity. The amount of exploration is very much contingent upon your physical fitness. So what is this saying? It's saying you don't want to go to Mars in 0 gravity if you want to actually get anything done, because you'd be deconditioned.